Most people think the main battle in the auto industry is being fought over design, batteries, or software. But the real war is happening somewhere else entirely, on the foundry floor. And there's already a winner. A 50,000-ton press is changing the rules of the game so radically that traditional automakers are facing a choice: completely reinvent themselves or disappear. How exactly one machine can wipe out an entire era of automotive manufacturing, that's what we are getting into. To understand the scale of what's happening, you need to start with a number. 50,000 tons, that's not just a spec, that's a clamping force of 500,000 kilonewtons. For comparison, the most advanced presses running in most factories today generate 16,000 tons of force. The new machine outperforms them by a factor of 3. This isn't evolution, it's a different dimension entirely. At that level of clamping force, things become possible that were previously considered technically unfeasible for mass production. Massive volumes of molten aluminum fill incredibly complex molds so fast that the metal simply doesn't have time to solidify prematurely. Older machines struggle to handle 80 kilograms of aluminum per cycle. The 50,000-ton press operates on a fundamentally different scale and does it without sacrificing quality. But the most devastating thing for competitors isn't the raw power itself, it's what that power makes possible. One standard large casting machine produces one structural component per cycle. The 50,000-ton GigaPress outputs up to 5 massive parts simultaneously. One cycle takes between 1 and 2 minutes. That means thousands of large components per day, with no increase in operational complexity. Now picture a traditional auto plant. 70 to 100 stamped steel parts welded together by hundreds of robots. That's how cars have been built for decades. The new approach replaces that entire structure with a single cast unit. The result is a 30 to 40% reduction in factory floor space, a sharp drop in labor costs, and a fundamental simplification of the entire logistics chain. This isn't optimizing the old system, it's eliminating it. And speed doesn't come at the expense of precision. Molten aluminum at around 850 degrees Celsius is filtered to remove impurities larger than 25 microns, smaller than the width of a human hair. Immediately after pouring, the casting undergoes thermal shock, rapid cooling from roughly 400 degrees down to 50. This locks properties into the metal that simply can't be achieved through slow cooling. Speed here is a tool. Precision is the law. This kind of process doesn't come cheap. A single 50,000-ton GigaPress runs between $43 and $65 million. Tooling adds another $1.5 to $2.5 million. But the logic is different here. Capital gets burned now to secure dominance permanently. Eliminating hundreds of parts, cutting out countless welding robots, simplifying the supply chain, all of this creates a fundamentally different cost structure. That's exactly what opens the door to an electric vehicle priced under $25,000, a price point that could reshape the entire market. In historical terms, what's happening now is comparable to the arrival of Henry Ford's assembly line or the production system developed by one of Japan's auto giants. But there's a fundamental difference. Those revolutions made existing processes more efficient. This one destroys the processes themselves, not reducing steps, eliminating them entirely. By 2027, which the industry is already calling the year of reckoning, the major manufacturers have found themselves in a state of forced adaptation. In Europe, the response has been cautious. One Swedish automaker is choosing a gradual rollout of 9,000-ton presses combined with modular architecture to avoid the risk of a catastrophic production failure. German conglomerates, long proud of their engineering precision, are watching with growing unease as gigacasting spreads on the other side of the Atlantic. In the United States, major players are pouring billions into building out casting capacity, desperate not to get pushed out of the market. In Asia, the pressure is just as intense. One Japanese leader is being forced to rebuild its entire EV platform from scratch, aiming to cut the number of production steps in half. Another Japanese manufacturer has set its sights on consolidating around 100 separate components into a single casting, with the goal of cutting costs and reducing structural weight. But this is where the fundamental problem lies. While traditional players are using gigacasting as a way to patch holes in an outdated system, their main competitor has built their entire manufacturing philosophy around this technology. At the power level of a 50,000-ton press, the gap between these two approaches isn't narrowing, it's growing exponentially. Why are two specific vehicles uniquely positioned to take full advantage of this machine? The answer comes down to one principle. Casting at this scale requires the car to be designed around the technology from day one, not retrofitted to it after the fact. Existing models can't switch to a casting-first philosophy without losing efficiency, driving up costs, or compromising structural integrity. The first of these vehicles is a robotaxi, no steering wheel, no pedals, built for autonomous operation in continuous service. A vehicle running around the clock as part of a fleet faces stresses that are incomparable to a privately owned car. That demands exceptional structural rigidity with the fewest possible failure points. When the core of the body is cast as a single massive unit, hundreds of welds and joints, potential sources of failure, simply disappear. Fewer parts means fewer breakdowns, lower maintenance costs, and faster repair cycles. For production at the volumes needed to build a global autonomous transportation network, the 50,000-ton press isn't just a tool, it's a prerequisite. The second vehicle solves a different problem, the price problem. With a target cost of under $25,000, the manufacturer is entering the most competitive segment of the global market, one dominated by low-cost producers. At that price point, traditional assembly methods don't deliver acceptable margins. Every part, every step, every second of production time has to be eliminated or compressed to the absolute minimum. This is exactly where the GigaPress and the assembly-free production philosophy work in tandem. Casting multiple chassis sections simultaneously reduces factory floor space, cuts labor requirements, and brings total cycle time down to levels that are simply unreachable with traditional assembly. Replacing hundreds of components with a few large castings eliminates not just material costs, but the enormous logistical overhead of a sprawling supply chain. This is a car that isn't so much assembled as it is printed by a system that removes thousands of parts and miles of assembly lines. The competition with manufacturers of ultra-affordable EVs gives this race a particular edge. A number of Chinese manufacturers have mastered mass production of low-cost electric vehicles, relying on maximum supply chain localization, low labor costs, and modular architectures. Some models show just how far you can push price reduction using traditional stamped parts. But that same approach reveals its limits in durability, scalability, and long-term efficiency. The key difference in strategies: some cut costs by optimizing existing processes. Others cut costs by destroying those processes. The first path fights for efficiency within the system. The second rewrites the system itself. The battle is playing out on two fronts simultaneously. One is a cost war through scale and cheap labor. The other is a technological gap driven by a manufacturing revolution. By 2027, the winner won't be whoever builds the cheapest car. The winner will be whoever redefines the very way it's made. Both vehicles, the robotaxi and the mass-market EV, share one goal: production at massive scale with radically low per-unit cost. The robotaxi is optimized for operational intensity and fleet durability. The mass-market EV is optimized for affordability and widespread adoption. The 50,000-ton GigaPress is the only technology capable of delivering on both of those requirements at the same time. That's why this isn't just about new models. These are manufacturing platforms designed from the ground up around the logic of gigacasting. In this framework, a car stops being something that's assembled. It becomes something that's cast, scaled, and deployed globally. If you're interested in following how technological shifts are reshaping entire industries, subscribe to the channel and hit like. It helps new content reach more people, and you won't want to miss what's coming next.